As you know, the universe contains millions of galaxies, billions of planets, stars, and star systems. Almost all these celestial bodies possess a wide variety of unique and fascinating characteristics. Perhaps the one thing they all have in common is that they rotate both around themselves and around another celestial body under the influence of gravitational forces. But why do celestial bodies, regardless of their size, rotate around themselves and orbit another celestial body? In today's video, we've explored these questions to bring you an insightful documentary with answers. Before we start our video, don't forget to subscribe to our channel and like our videos to help them gain more visibility. Additionally, if there's a scientific topic you're curious about and would like us to create a video on, please let us know in the comments. We will create videos on the most liked and intriguing suggestions. Now, let's get back to our topic. First, let us clarify that celestial bodies, which rotate both on their axes and around other objects, typically orbit around objects much larger than themselves. Taking our solar system as an example, the Moon orbits the Earth, while the Earth orbits the Sun. Similarly, the Sun revolves around a black hole believed to reside at the center of the Milky Way galaxy. To understand why celestial bodies are so eager to rotate both on their axes and around other objects, we must go back to the time when these bodies first began to form. Planets, moons, stars, and even black holes, all of these celestial bodies were initially nothing more than clouds of gas and dust. These clouds are commonly referred to as nebulae, as many of you may already know. Nebulae form as a result of massive stellar explosions, such as supernovae or hypernovae, which eject stellar material into space. These explosions release vast amounts of particles and dust into the universe. Due to the gravitational forces acting between them, these particles begin to influence each other and move accordingly. For example, if 10 particles are ejected into space following an explosion, these particles will gravitate toward the closest and most gravitationally dominant particle. As a result, they begin to cluster and move in different directions. Additionally, these particles and dust are launched into space with a specific momentum. In simple terms, every particle ejected into space possesses its unique gravitational pull, rotational speed, and momentum. As these particles interact and follow one another due to gravitational forces, they gradually come closer together and form clusters, eventually colliding and merging. When two particles collide, their combined mass after the collision must equal their total mass before the collision. This is a common misconception. Many people believe that two colliding bodies must lose mass in the process. However, this is not necessarily the case in space. The same rule applies to momentum and energy. The total momentum and energy before and after the collision just remain equal. Every type of collision just adhere to this principle of conservation. As the dust and particles in the gas cloud draw closer together and accumulate, they form clusters that grow larger and larger over time. These larger clusters eventually form stars, such as the Sun, while smaller clusters that fail to grow sufficiently become moons or planets. Our solar system was formed in this exact manner. The energy of the particles that make up these clusters determines the momentum, energy, and rotational speed of the celestial body that emerges after the formation process. This phenomenon is linked to the fact that massive celestial bodies, with all their combined energy, warp the fabric of spacetime. This warping gives rise to gravitational force. Due to the influence of this gravitational force, a celestial body orbits another celestial body with a stronger gravitational pull. This orbital motion continues indefinitely, essentially forever, unless disrupted by an external force, such as an asteroid or another object. So, why do celestial bodies rotate on their own axes? As previously mentioned, the particles that form celestial bodies possess momentum and rotational speed. Before they combine, these separate particles begin rotating in the direction and at the speed of the particles they follow. This can be likened to a snake. Wherever the head moves, and at whatever speed, the tail follows in the same direction and at the same pace. The particles that follow each other continue to rotate in the same direction and at the same speed even after combining, with no change in their momentum or energy. As a result, planets, moons, and other celestial bodies continue to rotate even after their formation is complete. To simplify the question of why everything in space rotates, the answer can be summarized as follows. the particles and dust that form celestial bodies maintain the direction, speed, and momentum they were given during the initial explosion, as there is no friction in space to slow them down. This rotational motion persists for millions of years. The only factors that can alter their speed, energy, or momentum are external influences. For example, millions of years ago, the planet they collided with Earth. This collision slightly altered Earth's orbit and shape from its regular pattern. As a result, Earth has been rotating in its current position and manner for millions of years. So, why do most celestial bodies seem to rotate in the same direction? Actually, this isn't true. The perception that all celestial bodies rotate in the same direction stems from a lack of in-depth research and the assumption that everything in space behaves like Earth and its moon, the Moon. However, some celestial bodies rotate differently from Earth. Even within our own solar system, there are planets that rotate in the opposite direction to others. For instance, Uranus and Venus rotate in the opposite direction, meaning from east to west, unlike the other celestial bodies in the solar system. It's important to note, though, that the majority of celestial bodies tend to rotate in the same direction. So, why is that? According to scientists, there are two main explanations for this phenomenon. The first, and the one that is most widely accepted, involves the formation of the Sun. During its formation, the particles and dust clouds collapsing toward the center acted like a toilet flush. As you may know, when a toilet is flushed, the water always swirls in the same direction. Similarly, the particles collapsing into the Sun during its formation created a vortex that forced other materials to rotate in the same direction. The second possible explanation is that during the formation of the solar system, a nearby supernova explosion produced waves that influenced the motion of all the celestial bodies in the vicinity, causing them to rotate in the same direction. As for why Uranus and Venus rotate in the opposite direction, the most plausible explanation is that during the solar system's formation, protoplanets collided with Uranus and Venus, altering their rotation. At least for now. This is the explanation considered most reasonable by scientists. The rotations of celestial bodies are actually crucial for each planet. These rotations directly influence the shapes of the planet's landforms, climates, and weather conditions. For example, consider our Earth. The Earth's revolution around the Sun causes seasonal changes and variations in weather conditions. Similarly, the Moon's orbit around Earth, along with its periodic approach and retreat, causes tidal movements in our planet's waters. In short, this phenomenon of rotation in the universe is, for the most part, essential for all celestial bodies. What if the planets collided due to gravitational force? Let's take Earth and Mars, which is believed to have once been similar to Earth, as an example to explore this question. First, if we look at this scenario realistically, such an event is one of the most unlikely occurrences. However, let's imagine that Mars somehow escaped its orbit around the Sun and began drifting freely through space, eventually heading toward Earth. From a human perspective, the immediate reaction would likely be an attempt to destroy or fragment Mars to prevent a direct collision, even if it means dealing with meteor impacts from its fragments. If the collision happens too quickly for humanity to take action, they would have no choice but to accept the impending disaster. For days, people would anxiously await the collision, only to witness the catastrophic impact when it finally occurs. The aftermath of such a collision would be devastating, with both planets severely affected and all forms of life wiped out. As a result of Mars striking Earth, Earth's orbit, rotation, and speed would likely be dramatically altered, much like what happened to Uranus and Venus. However, this would not be the only consequence. Since Earth is larger than Mars, it would likely fare slightly better in the collision. The impact would eject millions of fragments into space, which could eventually coalesce. If large enough, these fragments might form a new planet. If not, they might create a new moon similar to our existing moon. If one planet survives the collision, its surface would be covered in lava, and fragments orbiting the planet would continue to crash down over time. This process would add to the surviving planet's mass, potentially making it larger than today's Earth. In essence, Earth and Mars would merge into one entity. If the Moon remains intact, the new celestial body could gain an additional satellite from the collision's debris, becoming a dual-moon planet. Assuming Earth survives, it would take millions of years for the orbiting debris to clear. These fragments might combine with one another or fall to Earth's surface, reshaping its landscape and increasing its size. Over millions of years, Earth would likely absorb the remaining fragments and resemble a newly formed planet with a lava-covered surface. It would take hundreds of thousands, perhaps even millions of years, for this molten surface to cool. Once the planet stabilizes, could it support life again? That remains uncertain. As we discussed in previous videos, for a planet to harbor life, it must meet certain criteria. After such a collision, these criteria would almost certainly be destroyed. However, if the planet manages to stabilize and fulfill these conditions once again, life could potentially re-emerge. If these conditions are met, the new Earth might experience a similar evolutionary process to the one our current Earth underwent. Millions of years later, a new intelligent species might arise, asking questions like we do today. What would happen if Earth collided with another planet? Perhaps they would rediscover our technology, uncover records of the internet and other social platforms, and gain insights into our existence. Most likely, they would feel deeply moved and saddened by what they discover about us. As you can see, the reason almost every celestial body in space rotates is fundamentally very simple. While some celestial bodies spin so slowly that they seem almost stationary, the vast majority in the universe are bound to rotate. If these bodies didn't spin, perhaps what we call the universe wouldn't even exist. When you look at it, you realize that nothing in the universe exists without purpose. Everything has a reason. As humanity, we must stop causing harm to these awe-inspiring wonders, strive to understand them better, and work to preserve and enhance their beauty. That's all from us for today. Dear science enthusiasts, see you in our next video. Don't forget to subscribe to our channel, like our videos, and leave a comment. We love you all. Stay safe and take care.